going to look at multiplying polynomials in this section. First we have a monomial times a monomial. Remember, a monomial is one term, so no signs in between the pieces. This might look familiar to you, and we did this kind of problem with exponent rules. You can regroup if you like, pulling the things that look alike together. So the numbers and the x's and the y's, and then just use our exponent rules going across. So first for our numbers, they're going to multiply. For our variables, we will keep the base and add. And also for the y's, we'll keep the base and add. Don't forget the 1 that is on the first y. And we're done. Negative 10, x to the 7th, y to the 3rd. Next, we'll look at a monomial times a polynomial. And this one works like some problems you've done before. It's going to be a distribute problem. So we're going to take the negative 3x and multiply by each term inside the parentheses. So first we have negative 3 times 2 will give us a negative 6. X times x to the 3rd, remember you will add the exponents, so we'll get 4. On the next one, we have negative 3 times a negative 5 will give us a positive 15. For the variables, we will add the exponents, will give us x to the 3rd. For our third term, negative 3 times 4 will give us a negative 12, and x times x gives us x squared. And the last term, negative 3 times a negative 1 will give us a positive 3, and an x, parentheses, comes off. This problem is a binomial times a binomial. And we'll use what we call the FOIL method to help us remember how to get all the pieces multiplied together. The F stands for the first term in each set of parentheses. So the 2x is a first term and the x is a first term, and we want to multiply those. So 2x times x will give us 2x squared. Then we'll do the outside or the outer. Remember, you always take one term from each set of parentheses. So the 2x is an outside term and the minus 5 is an outside term. They're on the outside edge. So we'll multiply those. So 2x times negative 5 will be a negative 10x. Then we'll do the inside or inner, which will be 1 and x. Those are the inside. So we're going to multiply those. 1 times x is x. And L stands for the last term in each set of parentheses. So 1 and negative 5 are last terms, and they're going to multiply. So 1 times negative 5 is negative 5. Parentheses comes off, and you usually get like terms on the outside and the inside, and these will combine. And they are different signs, so they're going to subtract sign of the larger. And now we're done. This problem is also a binomial times a binomial. So we will do the FOIL method. We'll do the first term in each set of parentheses. So x times x will give us x squared. We'll do the outside edge. X times negative 3 will give us a negative 3x. We'll do the inside. 3 times x will give us 3x. And the last term in each set of parentheses, 3 times a negative 3 will give us a negative 9. Parentheses comes off, and then we'll notice the outside and inside terms will cancel each other to give us x squared minus 9. For this problem, they're trying to trick us. They're trying to get us just to take the 2 down with each piece. We're not allowed to do that because this problem is not a product. If it has a plus or minus in between, you cannot do that. What we could do is use the definition of exponent and write it twice. And then we would realize that we have a FOIL problem. We're multiplying 2 binomials. So we would do the first terms. 3x times 3x would be 9x squared. We would do the outside. 3x times 2 would be 6x. Inside, 2 times 3x will be 6x. And last, 2 times 2 would give us 4. Parentheses comes off, and this time the x terms can go together. 9x squared plus 12x plus 4. This problem is longer than a FOIL problem. It has a binomial times a trinomial. There are 2 techniques that we'll look at for this problem. One is to just distribute twice. Take the x times everything in the second parentheses. And then we'll switch and take the 2 times everything in the second parentheses. So first let's distribute the x. We have x times 3x squared will give us 3x cubed. X times negative 4x will give us negative 4x squared. X times 1 will give us plus 1x. And then we'll switch. So now we'll distribute the 2 times each term in the second set of parentheses. So we're getting 2 times 3x squared will give us 6x squared. 2 times a negative 4x will give us negative 8x. And 2 times... So now we're going to combine the like terms. There's no other x cubed term, so we'll bring that one down. The x squared terms can go together. Work with the coefficients, different signs, subtract sign of the larger. Plain x terms, different signs, subtract sign of the larger. And your constant term. We'll look at this same problem with a different technique, and it's a vertical format. Let's remember first how to do plain old arithmetic. And we would take the 2 times everything on top. So 2 times 3 is 6. 2 times 2 is 4. 2 times 1 is 2. Then we switch and take the 1 times everything on top. So 1 times 3 is 3. 1 times 2 is 2. 1 times 1 is 1. And then we add. It's the same technique for multiplying polynomials. You should write the longest one on top. So we'll write the 3x squared minus 4x plus 1 on top, the shorter one underneath, and then we'll multiply. So we're going to take the 2 times everything on top. So 2 times 1 is 2. 2 times a negative 4x will be negative 8x. 2 times 3x squared will be 6x squared. And then we'll switch. We're going to take x times 1. When we write it down, it needs to go in the x column. X times negative 4x will be negative 4x squared. And x times 3x squared, we need a new column, will give us 3x cubed. And then we will combine. we should have the same answer. This is just a different way of doing the same problem.